Okay, so this video explains what is the inverse of a function and how to find inverse of a function. What are conditions for the existence of inverse of a function? What's an identity function? And what's a self-inverse? Now, before we start understanding what an inverse is, we need to understand what's a one-to-one function. A one-to-one function means that for every one value of x, there's only one possible value of y. That's called a one-to-one function. Correct? So one-to-one function, for every one value of x, there's one value of y. So here you can see that the first one is a one-to-one function, y is equal to x cube. So every one value of x is having one value of y. A simple way to find out whether a function is a one-to-one function or not, you use the horizontal line test. So what you do is simply you draw a horizontal line. If a horizontal line cuts the graph at one point, it is a one-to-one function. Here in this case, if you draw the horizontal line, it cuts at 2 points. It's a many-to-one function, when many values of x are mapped onto the same value of y. If the function fx is one-to-one function, it will have an inverse function which we denote f raised to minus 1x. Remember, unlike indices, don't please write this as 1 over fx. If a function fx is many to one function, it does not have an inverse. So remember, y is equal to x square will not have an inverse. You have to restrict the domain for it to have an inverse. Properties of inverse function. If fx has an inverse function, this new function is denoted by f raised to minus 1x. It must satisfy the vertical line test, means it also should be a function. Has a graph which is a reflection of y is equal to fx and line y is equal to x. I'll show you that in an example that follows. It satisfies that f composite inverse of x is x, and f inverse of f is x. So this we'll be doing when we do composite function. When you do composite of the function and its inverse, it gives the x back. And y is equal to x is called the identity function. So if they ask you what's an identity function, it's simply y is equal to x. It's a slant line making an angle of 45 degrees. With help of mapping diagram to understand inverse, let's see this. If you have x and you have 2x plus 1, I'm just giving you an example. I took some random values. I took x as 0, 2, minus 1. If I put 0, 2 into 0 plus 1 is 1. If I put 2, 2 to the 4 plus 1 is 5. Minus 2 plus 1 is minus 1. So this is my function basically. A mapping diagram for this function fx is equal to 2x plus 1. F of 0 is 1. But if I ask you what is f inverse of 1, it is 0. F inverse of 5 is 2. F inverse of minus 1 is minus 1. So that's what your inverse is. So f of 2 is 5, but f inverse of 5 is 2. The same thing holds good for a graph. If from the function, if you're finding the value of let's say f 1.8. So f 1.8 is here. 1.8 will go higher. Yeah, f of 1.8 is 7. Correct? So from the x value, you look at the y value. But if you're finding the inverse from the y value, you find out the x value. So f inverse of 4. So yeah, here. I am missing that simply here. So f inverse of 4 is 1.2. F of 1.2 is 4. F inverse of 4 is 1.2. What is f inverse of 2? So you look at, so f inverse of 2 is 0.8. So that's how you write down the inverse. Okay, that's conceptually, this is how you need to understand inverse. The domain and ranges swap. The domain of the inverse function is equal to the range of the function, and the range of the inverse function is equal to the domain of the function. If you look at this example where I've shown, now the question is asking you for the following function. In black is the question given. Draw the graphs of y is equal to x and f inverse x. So you draw your line y is equal to x. And to find f inverse x, what you do is, your x is minus 2, your x intercept is minus 2, your y intercept will be minus 2 for the inverse. For the function the y-intercept is 5, here the x-intercept would be 5. Correct? So your domain is from -2 to 0. These are the x values for the function. Your range is from 0 to 5. For the inverse, your domain becomes a range and the range becomes a domain. So your domain is 0 to 5, your range is -2 to 0. Similarly here, you draw your line y is equal to x. If this is the function, this is the inverse. You reflect in line y is equal to x. Your domain and range, you can try writing on your own and check with this answer. Correct? So domain is from -infinity to 0. The graph is stopping here. Your range is 4 to infinity. For the inverse, the domain is from 4 to infinity and the range is from lowest value to highest value. So lowest value is -infinity, highest value is 0. Okay. Algebraically, to find the inverse, what you need to do is you replace your y with x and make x the subject. So I'm taking the first sum over here. So y is equal to 2x minus 1. You replace your y with x and your x with y and then make y the subject. So -1 will go as +1 is equal to 2y. So y is equal to x plus 1 over 2. You can replace your y with f inverse x. So f inverse x is x plus 1 over 2. So if this is the function, this is the inverse. Let's take the second one. If this is the function, to find the inverse, you replace x with y, y with x. Transfer the 4 on the other side. To get rid of the square root, to square both the sides. Make y the subject. That's your inverse. Similarly, you can pause the video and you can try the third one and check the answer with this, whether the answer tallies or not. You cross multiply, open the brackets, make y the subject, remove y common, divide. That's how we can find the inverse. Simple algebra, high school algebra that you must have done in your 8th, 9th standard. How to find the inverse. Okay. The next concept is of self-inverse. For a self-inverse function, if you start with a function and you find the inverse, it will result in the same function. Any function which has an inverse and whose graph is symmetrical about line y is equal to x and falls on itself is called the self-inverse. Example, show that fx is equal to 2x plus 3 upon x minus 2 is a self-inverse. So you start with this, you replace x with y, y with x, cross multiply, make y the subject. Correct? So you'll find that whatever the function is, your inverse is the same. This is called self-inverse. The other example of self-inverse is fx is equal to 1 over x. So you try finding the inverse of this is also 1 over x. So this is what we learned in this chapter, in this section. We learned what's a one-to-one function, a many-to-one function, how to use the horizontal line test to identify one-to-one function, what are properties of an inverse function, from mapping diagram, how do you read the inverse, from a graph, how do you read the inverse, I showed you Desmos, how do you sketch y is equal to x and sketch the inverse, how the domain and range, the swap, how to algebraically find the inverse, and what is the self-inverse. So a lot of concepts covered in this. So please go through this video several times.